In this video, we'll discuss some more example in disjunctive rules. See, like this is somewhat different. Like how will we eliminate an OR? When you have P, R, Q, this term is valid either when P is valid or Q is valid. Like there is no justification given whether P is valid or Q is valid. Okay, so whenever we have R in RHS, we want to eliminate that to get a solution for it, right? So in that case, R elimination goes like we take this side, like P as an assumption, and we derive that to certain terms, and we take Q as an assumption, and we derive two certain terms. If these two terms are equal, then we can say that the term that we have derived is valid. Okay, so this is how an R elimination works. And this video will be seeing some examples where we are using this technique. Okay, so first derivation is negation P or negation Q derives to negation P and Q. So in this example, now here in LHS, only one term is given and that is connected using R. So surely we have to eliminate this R then to get to this conclusion. So how can we do it? Like first step is take this as a premises. So the given premises is negation P or negation Q. Now, what we have to do, like when you want to break this R, we start with negation P as an assumption and we try to derive to this term. And similarly, we start with negation Q as an assumption and start to derive to this term. If that is possible, then we can directly say that the term that we have derived is valid. Okay, so now we cannot directly, like given two statements, with this we cannot directly go with any conclusion over here. So in this case, we want to make this, we want to conclude this. Okay, so this is the conclusion that is needed. So what we usually do when you have a single term in RHS to be proven, we can take the negation of it, the reverse of it. So already we have the contradiction rule. So we can directly take this P and Q as an assumption. P and Q as an assumption, and we try to prove that to be a false statement. Okay, so now fourth step is when P and Q is valid, then P is valid by R elimination of step 3. Now see, you have negation P and P. Is that possible to both to be valid? No, it is not possible, right? Either P will be valid or negation P will be valid. So this means that your derivation went wrong based on the assumption that you have taken. So this is called your negation elimination based on step 2 and 4. So with that, we can say that the assumption that we have made over here is wrong. So with that, we can give a justification as negation insertion based on step 3 to 5. We got the result as negation of P and Q. The one that the assumption that we have taken is false. So it derives to this term. So this is the conclusion that is needed, right? So this is the conclusion that is needed. So by taking negation P as an assumption, we derive to this conclusion that is needed. So assumption should not be overlapped. That is very important. So when I take an assumption, so I take this as an assumption and I conclude it over here. And negation P as an assumption and that concludes over here. So this assumptions should not be overlapped. Okay, so the second half is taking negation P as an assumption, we concluded as this term is valid. And similarly, the next step is by taking negation Q as an assumption, we have to prove the same. So I'm going to follow the same strategy. So I'm going to take P and Q as an assumption again. And when P and Q is valid, Q is also valid. This is by and elimination of step 8. And step 10 is we cannot have negation Q and Q to be valid in the same statement. So it means that it is false. So this is and elimination of, negation elimination of 7 and 9. Okay, we taken an assumption and we proved that to be false. So we can say that by negation insertion, the taken assumption is false. So 11th statement is negation P and Q. The assumption that we have taken as P and Q, that is derives to false, so it is not possible. So we take it as the negation of it. So this is negation insertion between step 8 to 10. On taking P and Q, we derive that to false. Okay, so now what we have done, we have taken an assumption as negation Q and we derive to this term negation P and Q. Okay, so with that, what we can conclude? So by taking the first term as an assumption, we derive to this term negation P and Q. And by taking the second term as an assumption, we derive to this term. So with this, we can give this justification is important, the way in which you write the justification. When both goes to the same conclusion, we can say that this conclusion is valid. And this is based on the statement as or elimination of step 1. And from 2 to 6, it proves the first term validity, 2 to 6. And from 7 to 11, second term validation. Okay, so this is how we prove for an R elimination. We'll see one more example in R. The procedure is going to be seen. The problems may vary and the rule that you substitute may vary. Okay, but the way in which we derive has to follow the same set of rules. Okay, I'll just take one simple example. P, R, P and Q, P. Okay, so now here, this is the given, excuse me. So this is the given premises and we have to prove P as a valid term or not. So first time is P, R, P and Q is the given premise, write it down. And second, now we cannot directly prove it. So here you have an R term. So how can you break this R? R elimination, we take P as a term and P and Q as an assumption. So first assumption is made as P as an assumption. And with this, what we have to prove? We have to prove it to P again. Okay, so this statement, you can directly stop it as it is. We have taken P and that is the conclusion that is needed. So stop this. And the third one is we take P and Q as an assumption. And with this, what we want to prove? We want to prove to be P. So we can use and elimination of step 3. When can you call this P and Q to be valid? When both P is valid and Q is valid, then only we can write P and Q to be valid. So with that, we can write P is valid. Got it? So this is another proof. So it says that both derives to P. Okay, that is the conclusion that is needed. So how can you write the solution? Solution is P by R elimination of statement 1 from 2 and 3 to 4, it derives to the solution. Okay, so this is another example for R elimination. Now we'll look into another example. Like I'll give 3 more examples so that you'll understand this concept well. Okay, so the next one is P R Q derives Q R P. Okay, so the given premise is P R Q. This is the given premise. So with this, what we have to prove? We have to prove Q or P. Okay, so first what we do, we take one term as an assumption and we try to prove that. So first we take P as an assumption. And what we have to prove? We have to prove Q or P. By R insertion of step 2, how will you substitute R here? See, when P is valid, we can combine that. We can connect that using R with any term. So that is also going to be valid. So you can write the statement as QRP. Okay, the reason is we know P is valid. So whatever term it merged with, it is also going to be valid. So this we got it, right? We got the solution by taking P as the assumption. And step 4 is now take the second term as an assumption, Q as an assumption. And we are going to prove when Q is valid by R insertion of step 4, you can write it as QRP. So this is also valid. Okay, when it is R, when you want to insert R, if one term is valid, You can merge that with any other term as per the conclusion that is needed. Okay, now what we can say, see here, by our elimination of premises 1, from 2 to 3 we conclude QRP, and from 4 to 5 we conclude QRP. So with that we can say that QRP is also valid. Okay, so this is how we have to prove. Take first term as an assumption, derive to a conclusion. Say take second term as an assumption, derive to this some conclusion. If both the conclusion matches, then the derived conclusion is valid. Okay, so that is how we have to prove. I'll give 2 more examples. Some mandatory conditions, some bigger problems. Now consider this example. So we have 3 premises, and out of this 3 premises, we have to prove as negation P. So first step is to write down all the premises. P implies Q, R, R. I'm sorry, it is Q. Q, R, R, first premise, and second one is negation Q, and third one is negation R. So these are all premises. Okay, so now what we have to prove? We have to prove negation P. So, but the problem is, like, we cannot directly prove it. Like here, it is all bounded. See, you have negation Q, negation R, but Q and R is bounded with an implication. So when you are able to break that, then only we will find a solution for it. Okay, so what we can do, we have to make some assumptions to break this implication. And what assumption we usually make? In the conclusion, we just have a single term. When you just have a single term, we try to take the reverse of it, contradiction of it, and we try to prove it as false. Okay, so what I do, I take P as an assumption. Okay, and when P is an assumption, by implies elimination of statement 1 and 4, I can write here it is P implies something and P is valid. So with that, we can say that QRR is valid, right? And the 6th step is when QRR is valid, now what it comes, it is an OR logic. For OR logic, can you do it directly? No. How will you break this R? R can be breaked by taking one term as an assumption trying to prove something, another term as an assumption trying to prove something. And what something we need to prove over here? See, we have taken P as an assumption, and here, over here, we want to prove this to be false. Then only we can say that we can take the contradiction of it for using your negation implication. Okay, negation insertion. So first, I'll take Q as an assumption. And 7th step is when Q is taken as an assumption, here it is negation Q and Q. Is that possible for both Q and negation Q to be valid? No. So it says that it is false by negation, elimination of step 2 and 6, we say that. Okay, so one assumption we have made and we have derived to a conclusion out of it. Now the next assumption is I'm going to break this QRR. So this next step is I'm going to take R as an assumption. And you have already negation R given. Is it possible to have R and negation R valid in the same statement? No, not possible. So it is also false. So it is based on negation elimination of step 3 and 8. So this is also proven to be false. So according to our logic, what we say when you want to break R, first you take the first term as assumption derived to something, and say take second term as an assumption derived to something. If these matches, then you can say that the conclusion actually matches. Both derives to false, so it is false based on R elimination of step 5. And the first term is concluded from 6 to 7. Second term is concluded from 8 to 9. I'm sorry, it is 9. Okay, so with that, we proven that to be false. Now, look carefully. we have started with an assumption and that assumption derives to false in this place. So with that, what we can say that? We can say that it is taken like it, this is your negation insertion of the assumption that we have taken in step 4 to 10. From 4, we have taken P, but that assumption derives to false over here. So with that, we can say that negation P. And this is the conclusion actually needed. See here, negation P is the conclusion needed. Okay, so when you want to prove something, try to find the relationship between the input and what output is needed. Okay, so I'll take one more example to understand this logic better. And the next example is like all these things comes under your R elimination category. P implies Q, R, R. Same thing like this. And you have Q implies S, R implies S. And this concludes P implies S. Okay, now I'm going to prove that with all these premises, we are going to prove that P implies S. Okay, and listen carefully when you want to prove implications. So first step, write all the premises. First step, P implies Q, R, R, done. Second, Q implies S. Third, R implies S. So these are all the premises. Okay, and here everything is tightly bounded with an implies. So we cannot break a implies without a single term. I either need a P or Q or S, R. So without that, I cannot break this implies. Okay, and in the conclusion, I need P implies S. Okay, so when this implication can be introduced here, when you start with P and if it derives to S, then you can use this implies, or else we cannot do it. So in that case, what we do, we take P as an assumption here, and I'm going to prove it, derive S with the result, with the remaining terms. If I am able to derive to S, then we can say that P implies S is valid. Okay, so now I'm going to break all the term. Now see, I have P and I have P implies Q R R2. So with implies elimination of step 1 and 4, I can write it as Q R R. Okay, so now it comes to the R terminology. How will you break R over here? R can be breaked by taking Q as assumption derived to something, taking R as an assumption derived to something. And what is the something that we want to prove over here? We want to derive to S. Then only the conclusion actually reaches. Okay, so I start with Q as an assumption. And when Q is valid, you have Q implies S over here. By combining these two terms, by implies elimination of step 2 to 6, we can write it as yes. Got it? I just need S. So it derives to S here. And 8th step is, I take the second term, that is R. I take R as an assumption. And 9th step, when R is valid and R implies S is valid, by implies elimination of step 3 and 8, I can write it as yes. Okay, so taking R as an assumption, it also derives to yes. Taking Q as an assumption derives to S. Taking R as an assumption, it also derives to S. So it says that by R elimination of step 5, from 6 to 7, first term is derived. From 8 to 9, second term is derived, and everything is derived as S. Got it? And the last resultant one is we took P as an assumption and that derives to yes. See, we have taken an assumption and that derives to S. So based on implies insertion from step 4 to 10, we can write it as P implies S. Okay, so this is the final conclusion needed. So this is how an R elimination works. Okay, so always listen carefully, Ma. Like we have to check what is your LHS and what is the RHS that is needed. When you want to derive something like implies, you have to take this term as an assumption, try to prove this term. And when you want to prove something in the left, in this conclusion as a single term to be proven, and in all your right hands, in your left hand side, we cannot break something, then it is better to take the negation of the conclusion. Okay, so this is how when or elimination works. Thank you.